pause to add the salt here, but I will have them add food. Actually, I add the food coloring because it's so messy, and once it gets on your hands, it's days before you can get it off. But I'll have them add the food coloring, and then I'll have them take an eyedropper, and this takes a little bit of time to explain how to do this without disturbing the water in the glass to the extent that it doesn't work. So that I teach them how to introduce the drops of colored salt water in the side with a minimum amount of turbulence, not using that word. And then I have them observe where that water went, and if you can tell, it went to the bottom of the glass. Get into the fact that salt water is heavier than fresh water, and so it sinks to the bottom. That's when I'll bring in the concept of tides, and that the tides are water that the pull of the moon pulls from the ocean up into the bays. In general, since it's salt water, it's heavier, and it'll come up in the bottom of the estuary, or the bay, I'll use that word as opposed to estuary, where the fresh water from the river coming down towards the ocean because of gravity will tend to be on top, while the salt water tends to be more towards the bottom. If you'd like, you can do another part of this experiment, which is bring in hot water from home, which I bring in a cooler, and I'll have the students color that, put a little bit in a cup and color it a different food coloring, and have them introduce it into here the same way they did that, and they'll see that the hot water stays on the top of this. So they almost make like a water sandwich with the might be green on the top, then the clear in the middle, and the red on the bottom. That requires a little bit more dexterity. If they mix it all, it won't work. And of course you want to make sure the water isn't so hot that it burns the students' fingers, but it's hot enough that it will indeed float. And that's when I get into the concept of hot water has a lower density than cold water. The other part of this experiment is I'll give the kids a piece of aluminum foil, have them shape it into a canoe type shape, and I'll have them float it in this small bin of water, and I'll have them put the golf ball in it. And we'll sometimes, depending on how much time we have, we'll count to see whose canoe will stay up the longest in the water before it sinks. But I use this to introduce the concept of ships. Even though they are very heavy, I talk about ships carrying automobiles, steel, and other very heavy objects, and yet they can float, and that is because of the shape of the ship. This is the concept that density is, you consider both the shape as well as the weight, and figuring out what gravity forces are and what buoyancy forces are. And that because ships are designed in such a way, even though they are very, very heavy and can carry very, very heavy objects, they will float because the shape allows the buoyant force to work on them. So that's floating and sinking. And as I said, sometimes, depending upon your class, you can get all that in a 45 to 60 minute time frame. And in other cases, you either have to omit part of it. I usually, the first thing I'll omit if I think there might be a time challenge, is the hot water part of it, because that tends to be a little difficult in terms of manual dexterity with getting that water to float. But it's a nice thing to look at if you can make it work with the green or blue on top and the other color on the bottom, the clear water in the middle. Let me just make sure I've covered our vocabulary words. At the beginning of each session, I go over the vocabulary words from the last session to kind of reinforce that learning, and then I'll also put on the board the vocabulary words for this session. So we talked about density, although I didn't define it per se. I didn't get into specific gravity. Got into buoyancy, did not get into the concept that the buoyant force is equal to the volume of the weight of the volume displaced by the object, because that's too complex for this age group. But we can get into the buoyant forces, working up salinity, the measure of the salt content of the water, and differentiating ocean water from fresh water. And then the concept of tides, as the ocean water is pulled up into the estuary, and how the different weight of salt water versus fresh water. So that's floating and sinking.